Hello, everyone, and welcome to section 4.6 in Precalculus. Today we'll be doing the graphs of all the other trigonometric functions. So we've already done sine and cosine, so today we'll do tangent, cotangent, secant, and cosecant. Starting off with tangent. Again, whenever you have a graph that you don't know, whether it's a polynomial function, a rational function, linear function, it doesn't matter, you can always just start by plotting points. So we have x and tangent of x. So you can get out your table, and you can see that tangent of 0 is 0, so I'm going to plot that point. Tangent of pi fourths is a nice easy one. It's 1, so pi fourths would be there. Pi fourths is 1. And when we get to pi halves, though, we run into some trouble because tangent of pi halves is undefined. So what we're going to put there is an asymptote. And then tangent of 3 pi fourths. So the reference angle is pi fourths. So it's still going to be 1. But since it's in quadrant 2, tangent is negative in quadrant 2. Getting out my forecast. So in quadrant 2, tangent is negative. So it's negative 1. So now here I am at 3 pi fourths and negative 1. Tangent of pi is 0. Tangent of 5 pi fourths is going to be some kind of 1. Now 5 pi fourths is in quadrant 3. So tangent is positive in quadrant 3. So at 5 pi fourths, I'm at 1. And then tangent of 3 pi halves is undefined. So again, there's going to be an asymptote. And we've done enough now that you can see the pattern for tangent. It's going to keep doing this. It's going to go from negative 1 to 0 to 1, and then an asymptote. In the other direction, I'm going to put my asymptotes at all the pi halves because that's where cosine is 0. Remember that tangent is sine of x over cosine of x. So whenever cosine is equal to 0, tangent will be undefined. And since cosine is equal to 0 at all the pi halves, tangent is undefined at all the pi halves. So I'm going to put in the rest of my 1s. Here's my 0, 1, negative 1. And tangent looks a lot like x cubed, except that it repeats over and over and over again because it's periodic. Because if you were thinking about it in terms of the unit circle, tangent, after it finished going all the way around the unit circle, it would repeat again. So let's just draw a unit circle real quick to try and make this connection for you. So tangent is the ratio of the y over the x. So in the beginning, when the y is nothing and the x is really long, that's why it's at 0. But as you keep making these triangles, look, the y keeps getting bigger and bigger and the x is smaller, so the ratio keeps getting greater and greater. But eventually the x is so small as to be 0, and you can't have that happen, and that's why you hit an asymptote. But then on the other side, once you cross pi halves, so here's pi halves on the unit circle, then the ratio is still going to be a really big y over a really tiny x, but since that x is negative, that's why you're going to get a negative big number way down here. And eventually it goes to 0 and it keeps going up like that. Do I want you to make the connection to the unit circle? I would love that. But not everybody gets that right away, and that's okay. What I do want you to do is have this graph either memorized if you're in honors or on your appendix if you're in CP. So the period is going to be pi. A period means how long it takes something to repeat. And it only takes pi for it to repeat. So if you were thinking of it starting at 0, then there's pi halves. And look, by pi, it's already about to start over again. So that's how you know that the period is pi. The domain is not all real numbers. You can't take the tangent of all the pi halves. So we're going to write that as all x not equal to pi halves plus pi n. What that allows us to do is to say, okay, I know it's not good at pi halves, but then if I keep adding pi, meaning all the other ones, in the end just means I can keep doing that, and then those are all the ones that don't work. But the range is all real numbers. Unlike sine and cosine, that just went up to 1, down to -1, up to 1, down to -1. Tangent goes all the way from negative infinity up to positive infinity. So it has a completely different range than sine and cosine. And of course, there are vertical asymptotes at x is equal to pi halves. But again, 3 pi halves, 5 pi halves. So how can I represent all those different asymptotes? Again, I can say plus pi n. That's how far away the next one is, plus pi. Or plus 2 pi, there's another one. Plus 3 pi, there's another one. So we just can say that simply by saying pi n. So this graph is the parent graph for tangent of x. As always, you must be able to shift, translate, stretch, and shrink the graph. And this is going to be our equation to do that. Fortunately, the rules don't change. The amplitude, I'm going to put this in parentheses because there's technically no amplitude. But of course, we are going to use A to stretch it. So we'll show you how you do that, but it is not defined, okay? But as always, negative A will flip the graph upside down. Okay, so you're not going to have an amplitude for tangent, but we are still going to use that A kind of like an amplitude. The phase shift is determined by C. That didn't change. The vertical shift is determined by D. That didn't change. And the period of tangent, which is normally pi, so unlike sine and cosine, so you are going to have to remember something new. So sine of x and cosine of x have a period of 2 pi. Tangent's period is only pi before it repeats again. But it's still determined by b, so that didn't change. But since its normal period is pi, the formula that we're going to use to determine the new period is pi over b. Here, the period was determined by 2 pi, its normal period over b. For tangent, the normal period is pi, so the formula will be pi over b. And we'll do some examples now to help you really get that. So period is the hardest one, so I'm going to start with period. If it helps you, you could rewrite this as tangent of 1/2 x. Always know this, 1/2 of a number is the same as a number divided by 2. Half of 100 is the same as 100 divided by 2. Some people really struggle with that concept, but different forms are good for different purposes. And in this case, people do better if the 1/2 is separate from the x, because then they can see that b is 1/2. So my period is going to be pi, not 2 pi, over the 1/2. I flip and I multiply. Pi times, instead of divide, 2 over 1, and I get a period of 2 pi. Okay, here's the big difference. Tangent is centered around the origin. You have to treat tangent differently. That's why we did it on a different day. If this had been sine, you would have started at 0, and now you would have said, oh, my period is 2 pi, I'm going to end at 2 pi. But tangent doesn't work that way. If tangent's period is 2 pi, that means that you want half, which is pi, on the left of 0, and then you want the other half, which is also going to be pi, to the right of 0. So tangent is going to go from negative pi to pi. That will cover a span of 2 pi, which is its period. Tangent is super nice to graph. In the middle, it's 0. In the middle of the middle, so at this point, at pi halves, it's going to go up to 1. And at this point, it's going to go down to -1. And it has this nice cubic shape. So normally tangent goes up to 1 and down to 1 at the pi-fourths, so pi-fourths in 1. But really what's important is that it's halfway. It's not always at pi-fourths. So it's halfway. And I can show you that. So if I were to make a table and I would let x be pi halves, then tangent of x over 2 would be tangent of what's pi halves divided by 2? It's tangent of pi fourths. And what's tangent of pi fourths? 1. That's why at pi halves it's 1. So you don't have to go through all that. Instead, you can just say the middle of the middle. But if you ever get lost for a minute, then of course you could always make a table. Now you do have to keep going. So you need to kind of go like that, even though you can't continue to do it. And same thing over here. This is going to be at 1, 0. So I imagine that I've come up. It's going to go like that. Okay. So notice I didn't do any shifting or anything on this particular one. I was just trying to focus on that period because tangent is centered around the origin, and that's different than anything that we've done. So I hope that was clear. All right, let's do 3 more. Notice I'm only focusing on one thing for tangent. Tangent's a little bit tricky, so I probably won't add too many pieces to the puzzle like we will for sine and cosine, where I might do amplitude and phase shift and vertical shift and period all in the same graph. I won't do more than 2 of those things for tangent. But these next 2, I'm just going to focus on one thing. So remember, tangent has no amplitude. However, that 3 does affect things. So it's going to go down because it's negative. And at pi fourths, it's going to be 3, not 1. So here's my asymptotes. I can go ahead and put them in right away because I don't see a period change. There's nothing in front of the x, so I know my vertical asymptotes haven't moved. 0 hasn't moved. Now, if this were positive 3, I would go up to 3 instead of 1. That's what that number does. So it is like an amplitude, but we don't call it that. But it's negative 3, so I am going to go down. And on where I would have been at negative 1, I multiply by negative 3 and I get positive 3. So it comes down like this. And then you have to keep making it. There we go. Of course, the last one, you're just going to kind of stop there. And that's how we draw tangent. I have one more, even though it's only partial. It's a pretty graph. I like tangent. So now we're going to do our first shift. Remember, the negative is opposite, just like it has been ever since we started lines. So it's going to go to the right pi fourths. Notice I don't have anything else going on. I just want you to focus on moving right. I never draw the original graph. If you had all these asymptotes and things and tried to shift it, it would be really tricky, which is why I won't ask you to do too much in a single graph. So normally I'm at pi halves. I'm just going to move over pi fourths, which is what all these units are. So now I'm going to go over to this one. And then once you have those 2, you can just keep counting 4 over. 1, 2, 3, 4. Because the period of tangent is pi. And then you can just think of that as the, just find the middle. So the middle is going to be 0. The middle of the middle is 1. On the other side, negative 1. And you got yourself a tangent. That's it. Not so bad, right? Hopefully. And 1. Go to the other side. Again, there's nothing else going on this one except that shift. and you're done. Now this last one does have two things going on. It has a period change and it moves down one. So of course the period is harder, and then when we're all done we can move down one. I personally, just like last time, amplitude and period are my first graph, and then my shift is my second graph. So my period is normally pi. So my new period is going to be pi over whatever b is. B is 2, so pi over 2. That's my b. Now think about that. Remember, the period is the hard one for tangent. You have to divide pi halves evenly over the y-axis. So pi halves divided in half would be pi fourths on either side. I cannot even begin to tell you how many people do this wrong. They see pi halves, they do pi halves on either side. But that would make the entire period pi. A half plus a half would make a whole. We want the whole thing to be finished by pi halves. So it's going to be at pi fourths, because then the total distance of the period, the cycle, is going to be just pi halves. And you can continue to do that all the way across. And then I still am going to do what I always do. In the center, it's 0. The middle of the middle is 1. The middle of the middle is -1. Now, I wouldn't do the whole graph. I would just do one little piece, just to kind of make sure you got it. It also, when I'm grading, it'll help me know that you're doing it correctly. But now you would shift it down 1. So down 1, down 1, down 1, and that's going to be your final graph. So I wouldn't do all of them, just that one. But then from here, you can either make your dots first or draw as you go. I'm all about the dots. So I'm going to make all my dots, and then I'll be able to go back and draw all my lines. There we go. I feel like I didn't do that first one right. The last one's always a little tricky there. There we go. All right, and that's how we do tangent. The most important part is that it has to be centered around the y-axis. Cotangent. So remember that cotangent is the flip of tangent. 1 over cotangent. That's how tangent is. That's how cotangent is defined. But in addition to that, cotangent is also the cofunction. So I'm gonna take just a minute and explain something that I think will really help you understand some things. Actually, I'm going to use a page. So we're not using this. You can just watch. Just watch for a minute. So sine looks like this. Goes up to 1, down to 0, down to -1. That's basically what sine looks like, right? So I'm sure there have been times when you thought, why did sine and cosine go together? Well, sine and cosine, I know I'm exaggerating when I say it, but that co means that they are complementary. And complementary, you might remember, means that they add up to 90. So they're related. So if you know what y is in a right triangle, you know what x is because they complement each other. They're off by 90 degrees. If this is 30, then this is 60. If this is 20, then this is 70. They always complement each other to make 90. Well, if you look at the graph of sine and cosine starts here, and then it ends up doing the same thing as sine. When you look at them on top of each other, they're the same graph, just moved how much? Pi halves, or 90 degrees. They are literally the exact same function, but just shifted 90 degrees. 90 degrees as in complementary. So why did I stop and explain that? Because with cotangent, cotangent is also going to be the shift of tangent 90 degrees. So where tangent wraps around the y-axis, cotangent is going to shift 90 degrees, and its asymptotes are going to be here. So tangent and cotangent are off by 90 degrees. But cotangent is unique in that it is also the flip of tangent. So since it's also the flip of tangent, I'm also going to make it upside down. And that's what the graph of cotangent looks like. And if you're thinking, well, I didn't really follow that, that's okay. You just have to be able to make the graph of cotangent. But for those of you that did follow it, it probably makes so much sense now why it's called cotangent. And of course, how you make the graph. It is the flip and the cofunction of tangent. Okay, there we go. That's cotangent. Its domain, so x can't be 0, pi, 2 pi, 3 pi, so any pi n. But the range is all real numbers. And the period is still pi. Just like tangent, its period is the same. They're cofunctions. They're very similar to each other. So you'll notice I don't have any other examples on cotangent. I really mostly wanted you to understand how it was created and what it looks like, but I will not be putting shifts and things of cotangent on your tests and quizzes. I mostly just want you to know basically what it looks like. However, I will be doing secant and cosecant. These are really interesting. Actually, I guess I have to use this page. All right, so for secant and cosecant, what I want you to do first is I want you to draw cosine. Draw cosine. Remember that secant is the flip of cosine. So that is literally what we're going to do. So I draw cosine. Cosine starts at 1, goes down to 0, then down to -1, back up to 0, and then at 1. I want you to draw the whole thing, not just one little period. I'm going to make mine dotted. I know you don't have the cool little dotting tool, but you might want to draw it lightly or in a different color. Now, there are certain times when secant doesn't exist. Every time cosine is 0, secant doesn't exist. Every time cosine is equal to 0, secant is undefined. So right here, pi halves, there's going to be an asymptote, just like tangent. At 3 pi halves, going to be an asymptote. At 5 pi halves, going to be an asymptote. So the domain is that x can't be equal to not only pi halves, but then if you keep adding another pi, all the pi's after that. So how do I flip this? Honestly, I love these. All you have to do is literally flip it. So I'm going to take this u and I'm going to flip it upside down. The green is secant. And then this one goes like this, and then like this, and then like this, and then like this. So if you draw cosine, drawing secant is as easy as drawing a bunch of u's. Its range is that y is less than or equal to -1, or y is greater than or equal to 1. It actually is never equal to numbers between -1 and 1 because it has flipped upside down. I will put a little star by period. A lot of people get the period wrong. They think that it's pi because that's when the u repeats, but this one's a downward u. So by the time it gets a whole upward u and a downward u, and now it repeats, it's 2 pi. And that should make sense because it's related to cosine, and cosine's period is 2 pi. So obviously, I would love for you to try to graph cosecant completely on your own. I'm sure that you can do it. But as you know, I'm going to do it for you. So step 1 would be to draw sine. So I'm going to draw sine. Sine starts at 0, goes up to 1, back to 0, down to -1, 0. I do want you to keep going because that's the only way we're going to be able to draw all of cosecant. I'm going to make mine dotted. Here we go. So there's sine. And then step 2 would be to figure out, oh, don't want that. Step 2 would be to figure out where, sorry, it just doesn't want to draw that small. Step 2 is where sine of x is equal to 0, make an asymptote. So right here, there's going to be an asymptote because cosecant is the flip of sine. And if you try and flip 0, you'll be undefined. So this is where cosecant is going to be undefined. And then step 3 is going to be to draw your u's. It's that easy. And now I have the graph of cosecant. And think about this. Why did they call it cosecant? It's cosecant because it is off 90 degrees or pi halves. They're related. They're complementary. And if you look at the secant and the cosecant, they're the exact same graph. They're just off by 90 degrees. In the same way that complementary angles, if this is 10, this is 80. They're off by, they add up to 90. Okay, so what is my domain? My domain, just going to erase this last step here. My domain is going to be x is not equal to 0, pi, 2 pi. How can I sum that up? Just pi n, every multiple of pi. Its range is the same as the last one. It's going to be less than -1 or greater than 1. Those u's start up at 1 or go down below -1. And the period is 2 pi. So what's really cool about secant and cosecant is you can graph anything. If you're practiced now on graphing sine and cosine, so to graph any secant or cosecant function, first graph cosine or sine. Notice the order that I put them in because secant goes with cosine and cosecant goes with sine, and then determine the graph of secant or cosecant respectively. So let's actually do those. So I'm not going to worry about this for a second. For just a second, I'm going to pretend that it's sine. So if it's sine, then I see it has an amplitude of 2. And it's going to have a phase shift. It's going to go not to the right. I don't know why I wrote that. It's going to go to the left, pi halves. And it's going to go down 1. on a quiz, when I say to you, how does this move? You can't write -1. You need to write down 1. You need to explain what the minus means. And luckily, there is no period change. So my original graph is going to be going up to 2. Oops, that's too small. No period change. It's going to go up to 2 and then down to -2. So that's the only thing I'm trying to do on my first graph. And whether or not you actually make a little dotted line is up to you. But now your final one, I'm going to move that to the left pi halves and down 1. So to the left pi halves and then down 1. So there's going to be my first point. The left pi halves and down 1. Left pi halves and down 1. Left pi halves, down 1. Left pi halves and down 1. So I do want to continue this all the way just to make it easier. And then I'm going to go ahead and graph this one using my dotted tool. I know you don't have that, but you can make a nice dashed line, right? So now I'm actually going to draw secant or cosecant. I'm going to switch to red and make my asymptotes. Okay, so notice what I did. This is a little tricky for people. My asymptotes still belong with this 0. Sometimes kids accidentally put them here. They're like, oh, but that's where it's equal to 0. But I'm accounting for the shift already. So it's this 0, that point where it would be 0. That's where it is. And then switching to a solid, once you have your asymptotes, you can go ahead and draw your cosecant. So I'm going off of the blue graph. It's nice and symmetric. But notice that this is where it would have been. That's like my 0 line. And there's my cosecant in red. So the final answer is the red. Red is the final answer. But it took me a lot to get there. The green was just to get my amplitude. The blue was my sine graph, but the red is what represents my final answer. So obviously I would love for you to try this next one on your own, but of course I am going to do it for you. So I think to myself, secant goes with cosine of 2x plus 3. I do see that it's going to be upside down. I see that it's going to be up 3. And I see there's a period change. Since b is equal to 2, the period is 2 pi over that 2, which is pi. So it's been a little while since we've graphed a cosine one. Let's take our time. So cosine normally starts at 1 and then goes down to 1/2 and then down to -1 at pi. But I need to finish by pi. So at pi, I'm going to end at 1, except it's upside down. So I'm going to end at -1. So I'm going to start at -1, end at -1, and in the middle, I'm going to be at +1. And in the middle of the middle is right there. So it's not that bad to do. So it looks like this. But I want to move that up 3. So I'm going to go ahead and move that up 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3. And now, because this is the one that I'm going to use, I'm actually going to go ahead and make it all the way across. I'm going to connect it with a dotted line. This is the graph of y is equal to negative negative cosine 2x, it's going twice as fast, and then up 3. Okay, now my next step is to, sorry, I gotta get all my little pieces here. My next step is to make my asymptotes. So I'm looking at this point right here. Can you tell that that's still my 0 point? Like if I were to put this on the line, that would be my 0. So this is where, oops, I do want it dashed. So that's where it would be. Lots of asymptotes for this one because it's moving quickly. So there were extra. Oh, and I just realized, see, this is why I make the dots everywhere. It didn't quite come out right. So it should look right to you. There we go. And now switching to red. Okay, last step. I actually get to make my U's. So there is a U there, even though it goes off our graph. And there's one there, one there. And this red one is my final answer. Some people even go back and erase the blue one. That would be fine if you erase the blue one, but don't erase the green one. I want to see that. If you've made a mistake, at least I can give you some partial credit and say, oh, they knew what they were doing, but they made a mistake along the way. All right, now you've learned how to graph tangent, cotangent, secant, and cosecant. Good job. Have a great day.